Hello, you guys can hear me? Yes? All right, great. Thanks for coming to my talk. Today I'll be talking about migration paths that we went through at Proximus. Proximus is the biggest telco company in Belgium, and it actually moved from a very old way of working, which I'll explain, to this brand new microservices hype, right? And how you can do that is actually a phased approach, which is pretty difficult, and you have to make sure you actually take into account all the different considerations. Okay, so first, who am I? I'm Andreas Evers. It's not really working. Okay, it's just slow. So I work for Ordina Belgium, it's a consultancy company, and I'm employed at Proximus as coding architect. And I like to contribute to open source projects, and as this coding architecture role, it's really easy to do that because we have to use these new toolings, and actually extending them to fit our needs as well is something really awesome. So where did we come from in Proximus? We started out like 10 years ago with monolithic server-side MVCs. I'm sure you guys are familiar with these kind of structures, and it looked a bit like this. So we had the browser, right, which is just calling a server-side MVC. They're like the yellow ones, different sites, different big blocks, which were written in Spring 1, so really early days. And then also using struts often. Then we switched over to Spring MVC, but still the old ones with the front controller and all that stuff. And they were running on WebSphere portal server, the 6, which is a pain in the ass, actually. I mean, WebSphere server is already pretty big and pretty hard to use, but the portal server was even worse. Although I'm not judging new versions, but the 6 was pretty difficult. Actually, some of the applications were also working with different technologies like Wicked, but in essence, there were all these monolithic server-side MVCs, right? So what we saw actually was that most of these monoliths were actually writing the same code, because they all had to connect to this red ESB, which exposed all our backend services. So they all had this common logic, right? So what did we do in a quest to reuse code? We created this library called El Nino, right? It's just a common library that was used in all of the monoliths, and that eventually has grown to be like a really big black box. Because this was coupled, this library was coupled in all these monoliths, we really couldn't change a lot there. So we had to be very careful. And we only could make additions, but we couldn't change anything. We couldn't even refactor anything, right? And that was really bad. So it became this black big box, which was really terrible to work with. So this was the very definition of legacy code. So after a while, we saw this and we thought, guys, let's do this better, right? So we put together the brightest minds of the whole company, right? In this Tiger team, who were going to do it well this time. Okay, so they built this common API monolith. Okay, this was the solution, right? We called it eFast because it was this functional API service and toolbox kind of thing. So we actually were calling from our smaller services, smaller monoliths, this bigger monolith over HTTP, and that was the idea. And all the business logic had to go into this eFast module, and actually the presentation logic could still remain in these smaller components at the top. But those were still server-side MVCs. So we were using TimeLeaf there, which was a new cool technology. But actually it didn't really change much. Because actually we had to use this shared model, which was really huge, really complex. It had to cover all the different scenarios, all the different functional flows of our entire application realm, basically. So for all these monoliths, it had to cover all these cases. Okay, so after a while, we also saw, okay, when we have it there in eFast, we need to also be able to to have this model in our clients, right? So we built these shared domain models also in our clients. That was shared actually. So the problem was that when you do this over HTTP and JSON, that it becomes really difficult to understand this in the client, to parse it, to deserialize it. So we helped out our client developers, and we actually built this eFost client. Okay, this was a library which just translated the JSON back into this complex model. Okay, so you actually just had a dependency on all your smaller monoliths to this model, this shared model, which really created a lot of coupling, right? So eventually, this became our next black box. And this was just the same, actually. We tried to do it over HTTP, but we actually just did it, included it as a library, so there was no change. It was just, again, the same coupling, and it was actually really hard to change as well. But of course, there was this Tiger team that was on top of it. So they really thought, let's do this right, let's apply the right techniques and the right principles and practices. So it was internally structured well, but because there was this feeling for quality, they didn't want anyone to work on it, right? Because it was all the other developers were stupid, right? So they had to do these reviews all the time, and there was this complete bottleneck situation. You couldn't change a lot because it always had to go through this Tiger team, right? So while it was good inside, it wasn't really useful. Okay, so that was actually our attempt, which didn't work out either. Okay, so we actually started out with a new approach. Okay, round 3 basically. So we did a 6-month proof of concept, which was really nice to do because in that company it's pretty hard to get this kind of free time to test out things. But we made lots of promises of speed, of user experience, all that stuff. So what we actually went to investigate was microservices with hypermedia. And I'm not sure, did anyone go to my talk yesterday on microservices and hypermedia? Okay, so quite a lot. Actually, what I explained yesterday was actually what we investigated back then in the proof of concept. So we looked at, for example, Spring Boot versus Dropwizard versus some other technologies like Vertex and Node.js. But actually we liked Spring because we've been using Spring from the start. And that was for us an easy choice because Spring Boot is really like the natural evolution of Spring. So it's the new version of Spring basically. Spring tries to abstract things already, and Spring Boot goes one step further and goes with this convention over configuration approach. Dropwizard is the same thing, which is a great solution if you actually don't want to use Spring. Because there are some people who don't like the complexity and how it's tightly coupled, Spring. So they try to go for Dropwizard, and that works well. It's this Jetty, Jersey, and Jackson approach. So if those technologies suit you well, then Dropwizard is definitely the tool to go for. But as I said, Spring was really in our nature, so we used Spring Boot. We also investigated hypermedia. Yesterday I talked about this shortly. Actually, we went for a HAL, which is a hypermedia format. It's actually on top of JSON. It has some extra tags which you can use. And the HAL is nicely integrated as well in Spring. Because there's Oliver Kirke from the Spring Data team actually started out building this Spring HDOS or Spring HDOS module or project, which helps the server to implement hypermedia really easily. But for that, you need HAL. So we went with HAL. Then we also looked at the Netflix stack, for example, Eureka versus Zookeeper. And actually, because Netflix works well together, which is also maybe a downside that it's not that easy to use components separately, although you can, but it's not as straightforward. So we went with as many tools from Netflix as possible. And then Zookeeper was also very nice. It had more features than Eureka, actually. But for us, it was sufficient what Eureka did for us. Okay, so there were also some other solutions possible, like etcd and console, but eventually Netflix was the way to go. So because we were going for Netflix, we actually were very lucky that Spring has this project called Spring Cloud, which is just a wrapper on top of Netflix stack, which makes your life really easy if you're already using Spring. Because Spring is, with Spring Boot, has this convention over configuration approach, and Spring Cloud just builds on top of that. So you just really don't have to do that all that much to get these components running. Okay, sometimes it's just a matter of adding one little annotation on top of your Spring Boot application class, which is already like a couple of lines of code, nothing much. And then you just have this complete Eureka, which is awesome, right? You don't have to do anything else. So aside from that, we use Spring Boot admin as well, which is just visualizing a lot of things. I'll just show some screenshots later. And then Spring REST docs, which is super nice tool to document your contracts, which are also very important in microservices. And with hypermedia, you need to document your contracts. And that helps us really well, also with the hypermedia constraint. So we actually had to do something called the inverse Conway's maneuver. Is anyone familiar with this, or with the Conway's law? All right, so it actually says that your architecture is always going to resemble the ways you communicate in your company, right? And vice versa, basically. So if you want an architecture which is microservice lines, then you got to change the way you communicate in your company. Okay, so you have to do this cultural change. You have to start talking to each other. This is super important, and that's something we had to go through. We are still working on that. It's nothing which is finished, because we still have some people who are on islands, and we see that it's very hard to communicate with them. Like, for example, we put an ops guy inside of our team, which facilitates the communication between dev and ops really, really well, because they know what's going on, and we actually know what the concerns are of the ops people. Okay, but for example, we have this thing called UFT, which is like Selenium, but then from HP. And we have this whole team who is responsible of implementing these UFT tests. Right? It's just Selenium tests, right? But in a less great tool, basically. And they are doing that like every day, right? So we actually use that team, but that team is on a different floor, and they're actually not that agile, so it's really hard to get it right. They sometimes don't even know what kind of cases we want to get implemented. So having some guy from that team in our team would just solve that, I believe. But we can't do that because we have all these silos still. So getting rid of these silos is very important if you want to do this microservice architecture. And then, so aside from DevOps culture, of course, because product teams is part of DevOps, you have to put everyone together in a cross-functional team. Aside from DevOps, we have this open source attitude. So people have to own their microservice. That's important. So you don't have this shared responsibility over the entire floor or multiple teams who share one microservice. It's one team that actually owns one or multiple microservices. And they are responsible to keep that code clean and up to date, and they have the power to say if something changes in that microservice or not. But of course, the problem arises that this could create bottlenecks. And you can actually have this fast again, like I talked about. That there's just, everybody needs that one microservice to be expanded, to have some more functionality, but actually, they don't have time, so nothing happens. That's very bad, right? So we work with these pull requests or merge requests because we use GitLab, and that works really well. And it allows people to contribute and to learn from code reviews, which are really nicely integrated. So if you're familiar with GitHub, this shouldn't come as a surprise. So what we did to do this cultural change is we applied this thing. Does anyone know where this comes from? Indeed, Spotify. Yeah, I heard it. That's indeed Spotify's way of working. So you have these different tribes, and you have squads, and chapters, and guilds. While we don't have that many tribes, we do have many squads, which are just Scrum teams, basically. And actually, if you work in microservices, you are just focused on your microservice, and you own that microservice, and you don't own other microservices. So how do you really communicate over cross-cutting concerns, right? To evolve the architecture, for example. Then you can do that we have front-end parts, like a web layer, which is Angular. So we have this Angular guild. We have also microservices guild and other kind of guilds. So that's actually a group where people come together to talk about this shared subject. Okay, and that allows us to work across different teams still on the architecture, because they get some time off from their regular projects. So they're actually working on that microservice, let's say 4 days in a week, and then the 5th day, they actually get to work on guild stuff, which is not specific to the microservices, could be whatever. Right? So that's a nice way of doing it, but that also makes it very hard to convince management of this, because we really had to go through a lot of selling to actually get this approved. Because actually you don't deliver any code, or you don't deliver any functionality. You do deliver code if you work on this guild, right? So they always want to focus on delivering functionality, but sometimes you also need to evolve your architecture. And with microservices, you're never done evolving your architecture. Okay, so that's the way we work. So when we go back to what we had before our 6 months of proof of concept, we still have that running, by the way, but we just put this new thing in the middle, which actually, we actually had this fast monolith, which we started cutting into functional blocks. But first things first, like on the top, there's these green boxes that's just the browser and Angular code running on the browser. So we had these server-side MVCs, and now we have client-side MVCs, which make it easier to work decoupled, because we are actually talking full REST with the microservices. And we do that through the gateway. So the gateway has actually this aggregated index. Because we work with hypermedia, we can work with indexes of resources that you can find on a microservice. So every microservice that exposes REST has this index, which has a couple of resources that you can actually navigate to. And on the gateway itself, we aggregate all these resources or these links, and we aggregate them into one big index, which makes it easy for the Angular applications to get to our resources, to discover them, and that actually is really a testament to this hypermedia principle. Okay, so aside from the Angular components, by the way, we are working with Magnolia, if anyone might be interested in that. So that's just the top layer. Then we got the microservices. Yeah, this is of course functional decomposition of the fast monolith. Right? So we had to find these seams in the monolith and then pull chunks out, which are functional groups. Okay, so not technical, because otherwise we're back in the traditional SOA world if you're technical grouping. Okay, so functional decomposition with bounded contexts is very important. And if you already wrote a monolith before, it's easier to do this because you know what's out there, right? So if you're starting out and you don't have this monolithic application yet, and you just want to dive into microservices, you have to be very careful about the way you compose your microservices and the contexts that actually group the scope. So the microservices are of course built with the 12-factor app rules to make sure they're cloud native, because, which I will go into later, we want to have a nice migration to the cloud as well. So of course we've got these other blocks. We have the gateway, we have the config and the registry, which are just microservice patterns that we apply. It's important to know all the patterns that microservices can use and apply them in the right way. Okay. So one of these things, these concerns on this is now we have a lot more servers that we have to spin up, right? When we had this monolith, it was easy because we just had one application. We deployed it and maybe a couple clones, but that's easy, right? We just had some Jbosses to run this. So at the start, we still had to do this. So we have our microservices, and they run on Jbosses. So we have hundreds of Jbosses. Super expensive, but the company has big pockets, so we don't care that much. But what we really do care about is that provisioning these Jbosses takes time, because it has to be done manually. We haven't invented Docker yet in this company, apparently, so Jboss actually is still required and takes about 5 days to get a server. Aside from that, you have the budget that has to be approved. It always gets approved, but it takes some time as well. So just to make sure that you have everything up front, we have to request this Jboss instance a month in advance. And then we're fine. But that's not very agile, right? Especially if you want to work in microservice and refactor a lot. Because you want to split things out of the microservice and put them in new microservices if you see that it's becoming too big or that your functional decomposition is not working that well. Okay, so that's the part which is really annoying. So we actually are in the process of getting rid of Jboss. It's a migration phase, by the way, so it's not something you can do right away in one time. And we actually replace it with a platform as a service. You can build your own. You can do your own stuff, you know, with Chef, Puppet, Ansible, Vagrant, whatever, or Otto is called now, right? But we actually don't have that many ops guys who understand all this, so we prefer to go for a ready solution, which is the platform as a service. And we actually chose for Cloud Foundry to do this because that's a bit of the de facto standard. We also have Azure running, but we actually prefer Cloud Foundry because you can also easily move from implementation to implementation. So now we're actually using Pivotal Cloud Foundry. It has some nice dashboards, but aside from that, we should be able to go to IBM or HP or whatever. So that's the way we manage our deployments. So it looks a bit like this then eventually. Then once we've deployed these applications, we got to run them. And the first time we deployed this to production, this was nightmare because actually we couldn't see what was going on when we had performance issues or if we had any errors that were coming through because we had all these floating components. Before we had this monolith, it was easy, right? You can just even debug it. But with this, you can't really debug that easily, especially if you have load balancers in between and even other different components which could influence what happens with your requests and responses. So for monitoring purposes, we added a couple blocks. We have Hysterics and Turbine from Netflix stack, and then we have Kibana, the Elk stack, and Spring Boot admin, which I talked about already. So for our log aggregation and analysis, Kibana with ELK, which is really easy to use. You've got a log stack to aggregate the logs, then Elasticsearch to search through them and to index them, and then Kibana to nicely show some dashboards. Okay, so that was one step we had to take, and actually we couldn't convince our management that we needed this up front. We actually convinced them after we sat 2 weeks in a war room after the first deployment, because they were getting super stressed out that they couldn't solve the problem right away. We said we don't actually know what's going on. We have all these log files from all these Jbosses, but actually the problem sometimes wasn't even in the Jbosses. Sometimes it was in the backend, and we didn't even know that it was coming through, because we thought it was like a functional thing. It was actually giving a 400 error, while that was a functional flow, but some systems were actually taking 400 errors as technical errors. So that kind of stuff we really want to see in some dashboards, right? Aside from this, we also have Hysterics, which is the circuit breaker pattern, and you can see them. You can see lots of integration points this way. You can see which ones are actually not working at real time, which ones are giving issues or timeouts or whatever. So this is one thing, right? To have Hysterics and all these circuit breakers visualized, but that's just for one application, for one microservice. Not even actually for one clone separately. If you want to see all your clones for one type of application together in such a dashboard, you have to use Turbine, which is an aggregator from Netflix. It's pretty easy to set that up, by the way. So once you got this, you still have one limitation. It's real time, and you want to make analysis after the fact, right? So there's something happened. You see that something's going on, but you want to learn from your mistakes, or you want to learn what actually went bad after that you've solved the problem. And for that, you can actually pipe this into another dashboard, Grafana or Graphite or whatever, and you can see them over time, as you can see at the bottom. You can really see how these circuit breakers reacted over time, over a long period. And that's not standard in the Netflix stack, so you really have to pipe this. Okay? So that's something as an addition, which is really useful. Aside from this, we also have all these functional blocks that talk to each other, and your requests go through all these different blocks. So you actually need distributed tracing. And for that, we use Zipkin from Twitter, which is just a dashboard. And it has some logic behind the screen, which actually is based on the Google Dapper paper. Is anyone familiar with Google Dapper? Okay, 2 guys. So you have these spans and traces, right? And actually, that allows you to nicely see where your requests took the most time and how did it go through the systems. Okay, and actually, if you use Spring Cloud, which we are doing, it's really easy to integrate this with Spring Cloud Sleuth, which is just a dependency. You just add the dependency, and all your requests get this extra metadata. And then you can really easily get this extra information in this dashboard. So that's just a breeze. Okay, so that's the way we do our monitoring. It's still not finished. We still have sometimes things where we crack our heads open, like what the hell is going on? We don't understand. But these things already help us a long way. And if you don't have these tools, then you're really going to suffer when you deploy to production. So after yeah, actually testing is a major concern as well, which at the start we didn't do that well. So we had to also convince people to really put more effort into this. There's much more effort required than just when you're doing a monolith, because you have all these network hops and all these things that could go wrong. So actually you have a couple microservices as a test case. So you connect from an Angular application through the gateway to some microservice to another microservice, and that one goes to some backend. You can also, of course, have backends in your microservice as storage, but whatever. So if you look at that in a different perspective, yeah, it works, nice. So you can actually see that you have these different layers. And that's the way we also want to test this. So of course, we test our microservice separately with integration tests on the contract, which is just contained, and we mock out anything else with wire mock. So that's nice. We also do, of course, inside unit testing all the way through. So that's the first thing that we also do with monoliths, right? That's straightforward. But then there's this other thing called consumer-driven contract tests, which we apply. So we actually test from a client how it communicates to a server or to another microservice. So from here you can see that the first microservice is calling the second one, and we actually want to know that what is this client, this first microservice, actually using from the contract of the second microservice. So we make these tests in Pact, where we actually test this is what we expect as a client from your contract. So that allows us to run this test as part of the build flow of the server, of the producer of the contract. Which is really nice, because let's say you have 10 clients, 10 microservices, or 10 Angular applications that are calling a microservice. And you refactor that so that actually 5 of them are no longer calling the microservice. Then it could be that parts of your contract are no longer used by anyone. Then you could either not know this and just keep backwards compatibility on this, keep supporting this, or you could actually know it, and then you have the flexibility to just refactor whatever you want. Okay, so that's a really important tool which we apply. So we do this with Pact and the Pact broker, which is nice and easy to use actually. Then, aside from that, we have this block here, which actually tests the Angular application. Easy, right? And we use Node-RED to mock out all the backend, so all this gateway calls. Okay, so from then on, we actually know if that's working, that our interface is working, that our application, our Angular application, which is a single-page application, is working as it should. Okay, so if there's a problem, then normally the front-end guys always get the call. They always get a call from business. It's not working, right? So they have to start investigating. Okay, we'll check. And then they check and they see, okay, it's nothing in our application. We are not receiving some data in a JSON, whatever. So, but they always get that first call. So they always have to jump in there. But with these tests, we can kind of ensure that everything is fine for that application. What's the next step is actually that you test with your microservices, right? So they can see that if those tests are going fine, then actually it's not even something with the microservices or the single-page application, because who's getting the next call? It's the microservice guys. After the front-end guys have said, it's not our problem, then the microservice guys have to investigate. Okay, so we test that end-to-end, and we mock out using something called Parasoft Virtualize, but that's just because we already have that in the company, and we have licenses. So you can use all other things as well. You can use WireMock there as well. So it's just a proprietary tool, which works quite okay. So once we've done these tests, we actually have another test, which is an end-to-end test with real test data. And then often that test is actually the one that fails. So all these other tests are working often, and then the other one fails, and then we know, okay, it's something with the test data, or it's something that was changed in the ESB contract or whatever. So that allows us to identify these problems much quicker where they are residing from. Because otherwise, you're always going to have these front-end guys investigating every single bug and just forwarding them. And that just takes a lot of their time. Okay, so that's kind of the way that we actually do our testing. There's one more thing which I'll go into later, is that if you do this stubbing of the backends, that you can actually use wiremock with snippets from Spring REST docs. But I'll get into that in just a second. So aside from that, we also had versioning. So we after the first release, we saw, okay, we have to make changes, and we still have to support older versions. Although I don't advise you to always version, just be smart about it. See if it's really necessary. If you can make the client evolve at the same time as you, then don't version. Only version when it's absolutely necessary. Okay, but we still had to do that in some cases, and we used content negotiation for this, which is actually the most restful way, I would say. HDOS, of course, allows you to version without, actually to upgrade without actually having an extra version. So it allows us to add links or remove links, and front end would actually not know that, or the client wouldn't know that, because he dynamically checks if links are there or not. So if something's not there anymore, they won't show some functionality. It's that easy. You don't need a version for that. So that helps us preventing to version. And then you have semantic versioning, of course, if you do libraries, that kind of stuff, with Maven or with Gradle. We actually semantically version so that people are aware when something is really breaking the backwards compatibility. We upgrade the major version, otherwise it's just a minor, so we take that into account. And we do the tolerance reader, of course, which is very crucial to avoiding all these versions as well. So if your client is actually only using 2 fields of a response which has 10, then don't break if you don't find 5 of these other 8 fields, because there might be a change in the server. So don't bind on that early. Only bind when you actually need a field. Okay? That you can do that with these JSON annotations, but it's important to keep that in mind. Otherwise, you are just coupling more than you should. Okay? So that helps as well to not version. So once we have all these versions and these contracts, we have to actually document these somehow, so that clients are actually capable of implementing them. This could be microservices or Angular. It doesn't matter if it's in REST. Then you have a couple of tools that help you with this. So the first tool is the HAL browser. Because we are using the HAL hypermedia format, HAL browser helps us a long way in this. And you have Spring REST docs that complements this. Spring REST docs can supply you some sample examples and responses, which are actually always accurate because they are generated from your integration tests. So they will never get out of date. Otherwise, your build will fail. So that's pretty neat. I'll get into that in just a second. And then we have this resource graph, which I'll show as well. If you have hypermedia, you have all these hops that you have to go through to get your resource. You have to actually traverse your resources. And actually, if you have documentation, you often don't see where your resources are behind, how they are nested. Okay, so that's the graph. I'll show each of them. So the first one is the HAL browser, which looks a bit like this. Is anyone actually using this already? 2 guys. All right, that's good, because it's actually a tool which is not that known, but it's if you're using a hypermedia format and it's HAL, this is for free, and it's integrating really easily. So you can see that you have, it's actually not shown nicely on the monitor, but on the left side you have all these different relations, which are like links that actually point to different resources. And then you can click on these green arrows which go to that resource, and then you can see links for those resources as well. So that's just very easy to navigate. This is actually a hypermedia client already, out of the box. So your clients that you're implementing, be it a microservice or an Angular application, actually should just do this kind of thing. It should be this with some graphics on top of it. Okay, so that's useful, and it also shows you, if you actually integrate it with REST docs, how they actually look like, some documentation. Okay, so how you do that is actually, this is actually a sample from Spring REST docs. So you have nice ASCII doctor format, which is actually just a format which is designed for writing like Markdown, and then it gets translated into HTML by default, just standard. And then you see this. and you can see all kind of stuff like example success requests and responses, but also the negative flows. And you can see also tables of fields in your request body and response body, headers as well, and also links, what they actually mean and where they have to point to, and what you will find when you go there. So that's REST docs, and then you can, well, actually how you do that in the code, it might also show. So is anyone using mock MVC from Spring? Okay, then it's actually really easy, because mock MVC is just making calls for you to your endpoints in your microservice. And you can say, for example, mock MVC perform, go to the root, and then expect that you're getting a 200. That's straightforward, and it will make a request and a response. Okay, and then it will actually assert to the response that it's a 200. So that's all working normally, but you can also use this. You can also use, for example, Rest Assured or other libraries which do similar things. And then you just have to plug in this documentation part. So and do, and then document, and then you have the index. So this is calling the roots, which is an index with all kind of links. And you get back these, you can actually say link with rel, alpha and bravo. So I expect a link to be returned with alpha and bravo, and the description has to be this. That's actually your documentation. So what happens if you don't have bravo anymore in your response? Then your test will fail. So if you add a new field, for example, Charlie, and you don't add it here in your documentation, then actually your documentation is not up to date because it's missing the description of that link. So what will happen? It will assert the response, and it will actually fail your test. So that's a nice assurance that your documentation is always up to date. And you can do that as well with links, with fields, with headers. So that's pretty useful. You can also add constraints, by the way, which tell you more information of how to use these resources. So how does it integrate? You have these little books here, the docs part, and you can just click on it, and then the right side will change into a documentation view. So then you can just go through it and see how you should actually call this resource, which is actually including some of the samples which allow you to easily, for example, if you have a post that you have to do, to easily have like a sample for making that post. So the next thing is this resource graph. As you can see here, this is just D3GS, pretty straightforward, and you can integrate this with your API as well, with all your microservices, by the way. And then you can see which resources are nested in which other resources. And then you can also click on them, and if you click on them, you get that same REST docs documentation. So this is all really useful if you write Hypermedia API. But for REST docs, for example, you don't really need to use Hypermedia or links. You can also just use this for getting these snippets, these requests and responses, and these tables for fields descriptions. So it works also without Hypermedia, so that's useful. But this one, of course, just for Hypermedia because you have these nesting links. So aside from the contact that you have to document, you also should document your microservices themselves. Like how do they connect to each other, and actually across different layers. So how you can do that with just getting a view of what your microservices are, where they are, that's Spring Boot Admin, and Eureka can do that. And then we built something ourselves, Microservices UI, which show you how the different layers connect to each other. I'll show them as well. So the first one is Spring Boot Admin. It just shows you a link of all your microservices that are available and that are running at the moment. And you can click on the right side, the details button, and then you get these overview pages. If you use Spring Boot, then you have these actuator endpoints, which are just JSON, and they are really nicely shown in this UI. So you can see all kind of details about your microservice. Also counters and gauges that you can implement yourself. Then you can also do logging, for example. You can do also on top there's like GMX, so you can see a GMX dashboard. You can do a thread dump, which is nicely shown in your UI as well. And you can do trace, which shows you which requests and responses came in and went out of your service recently. Okay, so that's useful. Also environment variables, by the way, which any kind of environment variables that your application has access to. And that's all nicely shown here. But that, of course, you have to use Spring Boot for that. So we also have Eureka, and this is actually the Spring Cloud application, the wrapper around it, which is just like 10 lines of code in total, and you get this dashboard for free. So it's just a Netflix Eureka with a dashboard on top of it, and it shows you which applications are currently registered. You can also see leases, and the last 1,000 in startups show you the history of registrations and heartbeats. Okay, so that's a useful tool we also use. Aside from that, we also have built our own stuff. That's the Macroservices graphical user interface. So this is still looking really not that nice. We should put a graphical designer on that. But the idea is that you have these different layers, and that's what I also showed in my in these slides of the migration. You have the user interface, which are the green boxes. They have Angular components, which can be put on any kind of page, on any kind of application, so you can move them around. So it's important for us to know which Angular component is actually calling at a certain time a microservice. So we deduct this information, and we can tell, okay, this component is calling these RESTful endpoints. That's the second column. RESTful endpoints, resources, and we still have to make them more integrated with this hypermedia nesting thing. So they call these endpoints, and these endpoints are, of course, exposed on a microservice. So then we show which microservice they are actually on, and then on those microservices, you can see how they connect to other microservices and how they connect to backend resources. Or you can also see if there's a storage from themselves, they're also in that backend part. So that's a way to see how your system is actually connected. And after a while, your microservice can become really complex, and this is then a really necessity to debug, to know also what is where. And for analysts, this is a super important tool. They have these green buttons at the bottom, which allow them to add virtual nodes to each of the columns. So it's because if you're analyzing microservices and you're trying to put some functionality somewhere, you have to know what's where and what's coming up as well. Because it doesn't mean, this is actually live from when it's actually deployed. So it's taking that from the runtime. So that's it's useful to have some kind of a virtual representation of what's coming up, and they can add that themselves, and they can then connect through the use of some forms which nodes will be calling what in the future. So it's a useful tool. It's open source. You have the link there, and feel free to also contribute if you want, or to make some requests, and we can maybe see how we can do that. We can actually create it more generic, not specific to our topology and our way of working and our architecture. So that's actually the way we document stuff. Okay. So then actually we've gone through lots of migrations, and they're all as important to go through and not to forget. So you have cultural migration, which is maybe the most important one, because without the cultural change, you will not be able to maintain this. It will be a ticking time bomb, and eventually it will blow up. Architectural migration, of course, you have to change the tools you're using and the way you're developing them. Then deployment migration, we started out with the Jbosses, so it doesn't mean you have to go, you have to start with Docker first. It could be nice to start with that, but that's not something you start out with when you jump into microservices. There are ways to migrate more steadily from we use these application servers to eventual complete platform as a service that we have. But it's not a prerequisite. But you have to make that migration, also in DevOps. If you don't do that migration fast enough, so we had like at a certain point 50 microservices, and our DevOps was not migrated fast enough, so we weren't talking to people a lot. We actually we're still using that Jboss part. If you don't do that at the same pace, then you're going to be in big problems. But if you do have enough resources to make this migration at a steady pace, then you're fine. It should be fine, I believe. So for monitoring, it's to help out the ops guys, but not just the ops guys, because in DevOps, ops guys are in the team. So you help out the friend in your team, and eventually also the developers who, in the Amazon way of working, have to build it, ship it, and run it. Right? But that's a migration. It's not something which all developers can jump right into, because they don't always understand the complexities of operations. And then the testing, of course, it's crucial to test, because if you want to do continuous delivery, which is a crucial part of what we are doing, you have to make sure that any change you make is never going to introduce these changes, what's it called? Regressions, right? That's very important. And that's also something which we were struggling with a lot. And hopefully with this consumer-driven contract net and the full regression suite, this is something we actually fixed. But not to forget, okay? And then versioning migration, it's for the future. Better think of it up front, but eventually you're gonna need this. And then documentation migration, also for the ops guys, but also the analysts, and everyone in your company is going to be much happier if it's documented nicely. Okay, so I think that's it for my talk. I have a bunch of links here which go over the technologies that we use. There are a couple missing, but these are for us the most important ones. I think the ALK stack is missing, but yeah, I think yeah, that should be it. Okay, so if anyone has questions about the way we are working or the migration paths or the tools we use, then I'm happy to answer any questions. Yes? Yeah, well, we work with GitHub, with GitLab, right? So actually, a day in our team is just we work with Scrum or Scrum Ban or Scrum Kanban, like a merger of the two. Actually, it's not very religious, and people can just pick up a story and then work on that story and implement it, and then actually just use Jenkins, because that's what we use as build server, to start pushing this. Right, and the only thing we have to do now is CF push, right? Well, then it gets pushed to our development environment, where they can test in the cloud. We are also looking into other solutions to run it locally, more as a cloud, but we are now just using the development space. And then on the development space, if it's fine, it can be pushed to ITT or a testing space, and then from there on, anyone can test it, but it's also where our full regression suite runs with test data, with real test data. The other environment, the development environment, also runs the full test suite, except it's not using the real test data, because I mean it's taking way too long basically to get this test data, and also the test data gets flushed every couple of months, so it's not really reliable. So we try to mock everything out, stub everything out when it actually goes out of our microservices realm. So that's useful for us. And then once that's running, we have the option to automatically push to staging or not. Depends. Some teams like to do that, other teams don't. And then after that, it's just pushing to production with a big red button, right? But that's something business has to agree on. So that's the way we actually work. Any more questions? Yeah, sure. Mm. Yeah. Actually, we've got a couple enterprise architects who are looking into this. We are behind WebSeal, so everything is normally pretty secure. But we don't. I mean, management doesn't trust the developers really that much. Well, they should. So they want us to implement this service-to-service authentication. But for now, it's just there's not that much authentication between services because we trust ourselves, right? But management wants this eventually, and then we might be using something like OAuth on all the services with their own store, their own broker, and that's the next step. But we actually trust our developers to not have one service and then put some spyware in there and then just get all the information through the microservices, because they can call from one microservice all the other microservices, and eventually all these microservices will be able to call that all the backend services through the ESB, because we actually get security on calling the ESB. So your microservice is not supposed to call a method on an ESB which it doesn't on the ESB which it doesn't require. But of course, if you take the full microservice stack, we get all the data basically. So there's some work to be done there, and we are looking into OAuth for authentication between them. But for Angular side, we use JWT tokens, GWT, the JSON Web Tokens, and that actually is like we like to have session, but then not on the server because it would be state, but on the client, and that's then the Angular application. So we put actually parts of our session as part of JWT tokens on our client, and then the way we actually authenticate or we authorize the use of some information is through that JWT token, because that's with the secret, right? So you actually validate the secret if the secret is tampered with, or if the data is tampered with, you know actually, because it doesn't match. So that's kind of security, but yeah, we still have some work to do there. Although for now it's still secure from the outside, so that's fine. But from the inside, we need to start not trusting our teams that much, actually. So I hope that answers your question. Okay, there was another question, yeah? Ah, okay. But just come to me after the talk, and I'm here also the whole day. So thanks a lot, guys, for joining my talk.